We just tested on Chapter 2, which talked a lot about lines and graphing lines. Now we're going to look at a system of lines, which is just two of them together. We want to solve them, which means we want to find out where they intersect, if they intersect at all. The first method we're going to look at is by graphing or looking at a table to solve the system. First, there's a typo in the packet, so if you can, please change your second equation to what I have written here. Next, let's graph each of the lines. So this first line I'm going to graph in black. I'm going to plot the y-intercept of -2 and then use the slope of 1, that's the number in front of the x. So I'm going to go up 1, right 1, up 1, right 1, and continue that pattern throughout the graph. You want to also continue in the backwards direction, so down 1, left 1, down 1, left 1. Connect your dots in a nice straight line. Now let's graph the second equation. The second equation has a y-intercept of 4. I'm going to graph this one in red. The y-intercept is 4, and the slope is -1. So that means I'm going to go down 1, right 1, down 1, right 1, down 1, right 1, and continue that pattern. Notice I crossed the other line. Go ahead and connect your dots. The intersection point is the solution of the system, and the coordinates of that point is 3, 1. So that is how you solve by graphing. You could also throw this in your graphing calculator. Put both equations in your graphing calculator and plug it into the table. Now my computer is showing an Inspire calculator. We have an 84, but it looks similar. You can see I have a graph and the calculator table pulled up. On the right hand side, I'm at x equals 0. The first function has -2 value, the second function is 4. If I move down, I'm looking for when the second two columns are the same. And here you can see I have 1 in both columns, and the x value is 3. So the intersection of the two lines is 3, 1, which is exactly what we had in the notes packet. Let's try another one. Now in part B, we have two equations, but unfortunately they're not in mx plus b form. So what we want to do is change both of them into this form so it's easier for us to graph. So the first one, I need to add, let me write it down first. We want to get y by itself, so we need to move the x term away. So I'm going to add it to the other side, and I like to keep it in front of the 8. Now I need to get y by itself, so I'm going to divide the 2. Make sure you divide each piece by 2. So I now have y equals 3/2 x plus 4. Notice the number in front of x I kept as a fraction. So let's graph this. The y-intercept is 4, so I'm going to plot a dot at 4. The slope is up 3 over 2, or right 2. So I'm going to go up 3, right 2. I can't do it again because I'll go off the graph, but I can go backwards. Down 3, left 2. Down 3, left 2. Down 3, left 2. Connect your dots in a nice straight line. Now you want to do the same thing with the second line. So for the second line, I'm going to recopy the problem, and I need to get y by itself. So I need to move the x term over by subtracting it. I'm going to put the -x in front of the -8, divide both sides by 2. When I do that, I get -1/2 x minus 4. So I'm going to plot the -4 first, and then my slope is down 1, right 2. Down 1, right 2. So down 1, right 2. Down 1, right 2. I should also go in the opposite direction, which would be up and left. Up and left. You can see I just landed on top of the other line. That will be your intersection point. Happens right here. What is the coordinates of that point? You can't just circle it. Tell me the point. And it looks like it'll be -4, -2. We can confirm that in the calculator. So in y1 for your calculator, you're going to write the first equation, 3/2 x plus 4, and then you're going to go down, and in y2, type -1/2 x minus 4. If you want, you can use -0.5. It might be easier to type that. Let's see what it looks like in the calculator. So I've graphed both equations in my calculator, and you can see the table. And here at the top row, I have -4, and then the two y values are both -2. So that's where they intersect, at the coordinates x is -4, y is -2, which is what we had over here. Now in both equations, we had intersecting lines in both examples so far. When you have intersecting lines, we call this consistent and it's independent. Consistent because we get a solution, independent because there's independently only one solution. Here we have the two lines laying on top of each other. We have the red line and the blue line. So where do they intersect? They intersect all the time. So we call this infinite solutions because they cross so many times you can't even count that. This means it has an answer, so it is consistent. It has an answer, but it's dependent. Depends on what answer you want because there's so many different answers. Independent, there's only one solution. The last picture here shows parallel lines. They don't cross at all. That would be a no solution. So what would we call that? This would be inconsistent because we can't figure it out. Inconsistent. So what does that look like in an equation? Let's look here. In problem 4, we need to get both equations, get the y by themselves. So in this top one, I need to move the x term over by adding it, and then divide everything by 4 to get the y by itself. So I get y equals 1/2 x plus 6/4, which will reduce to 3/2. In the second equation, I need to divide everything by 8 to get the y by itself. When I do so, I have 1/2 x minus 12/8 reduces to 3/2. So now look at the two equations. They have the same slopes. If they have the same slopes, that means they're either lying on top of each other or they're two parallel lines. Since the b values are different, that means they are not the exact same line, they are parallel. And that would mean this would be inconsistent solutions.